This is Lab 7 Hints. In this lab, we're going to try to figure out what the rotation rate of the sun is. So the first part of this is really preparation for 7 days in a row. I want you, around the same period of time or same time of day, go to the SOHO website that I've pointed out here. And this is SOHO's a solar observatory. It's a satellite that's out that just takes pictures of the sun every couple of hours. I want you to take 7 pictures. Now there is some sunspot activity right now, I'd like you to use those pictures, but if you've run out of time or whatever, you feel free to use the pictures from 2002 that are available on the website. I think it would be a little bit better though if you could just use some new pictures. Now when you print these pictures out, make sure that they're all the same size or else this is not going to work. Now what we're trying to do is use ratios to determine the period of the sun. So the distance that a sunspot is going to move around the sun in a certain amount of time is going to be the same as the distance around the sun at that point divided by the time it takes to go around. So what we're going to do is we're going to make measurements of how a sunspot moves from day to day and use that to compare and see how long it takes for it to go completely around the sun. So the SOHO website lines up all the photos so the axis of the sun is down the center of the photo. Your data will be better for spots toward the center of the sun due to the two-dimensional nature of the pictures. So in other words, as we're looking at the sun, look for sunspots that are in this area here and towards the center, not sunspots that are up at the poles. It works better if you use this area here of the sun. Now I want you to just take 2 pictures that are 1 or 2 days apart, find out how far the spot has moved as well as the distance across the photo at that latitude. What do I mean by that? What I mean is if I look at, let's say I have a sunspot that's right here. The distance across the sun at that latitude would be drawing a line straight across and measuring the distance from the edges of the sun, not always through the center of the sun. I want at the latitude of where the sunspot is. So calculate T from your picture data and record it in hours. So the pictures might say this was taken on this date at this hour. And if you have one that's 2 days later but an earlier hour, that might be like 46 hours difference. So from just that information, we're able to calculate the time from our picture data, and we can use that to solve for the period of the sunspot. I just want you to repeat this for different combinations of pictures and spots. And I want you to do this for about 10 times and take an average. When it's finished, scan your pictures with your measurements written on them, and the following data sheet as a PDF, submit it in Angel as we've done before. I'm going to take you through an example calculation now. So here's an example of how I did it. I took 2 pictures. So I'll start off with this picture. And I've determined a sunspot that I'm going to use there. And I drew a picture, a line across it. Right? So now, the first thing I'm going to do is measure the distance from the edge of the sun to the sunspot. In this case, I measured it was 42 millimeters. Now, at a different time here, in this case, looks like I chose, this was the 11:14, this was 11:15, so this is 24-hour difference between these pictures. I drew a line across the same latitude, and now from the edge of the sun to the sunspot is 55 millimeters. I also then measure the distance from this edge of the sun to this edge of the sun at that latitude, and it's 77 millimeters diameter. So the time I would record in my data sheet, in this case, is 24 hours. It moved from 42 millimeters to 55 millimeters, so I subtract those. It moved 13 millimeters in the units of the printed page. So now I can use the equation that we had and solve this for t. The period is the time it takes times pi times the diameter of the sun over x. So in this case, the time it took, we said, was 24 hours. Pi, of course, is just 3.14. D is the diameter of the sun at this point, which I said was 77 millimeters. x is the distance it moved, which was 13 millimeters. So I don't need to redo this algebra or anything. I just need to plug these numbers into this equation for yours. And in my case, when I solved for that, I got a period of 446 hours, or 18.6 days. Now, we know that it's between 25 and 35 days, so there's some error here, and that's okay. What I'm trying to get you to understand in this calculation in this lab is the methods that we can use to measure something like period using pictures. So again, take this data table, take several sets of pictures, measure x, the distance that it moves between two pictures, the diameter at the sun at that sunspot, the time between the pictures, and use this equation to figure out the period. I want you to do that for several different sunspots at different latitudes. And when you do, you'll get 10 different numbers, probably a lot different. I want you to average those to find the average period. Now, I've mentioned what the actual rotation is. Look it up in your astronomy book. How far off? And maybe think a little bit about what we could have done differently to get a more accurate answer. I just want you to think through, write a few sentences on things that you could have done differently. And then write a few things that you learned in this lab that you didn't know before.